Hey, so this video is going to be the first in a really, really long series of videos on algebra, just really basic intro to algebra. So basically solving linear equations in one variable. Because there are so many videos in this particular series, I think I'm going to do it in 3 parts. So part 1, we're just going to look at solving linear equations in one variable. Part 2, we're going to look at problem solving or word problems. And then part 3, we're going to look at solving linear inequalities in one variable. So this is going to be part 1, video 1 in the series on solving linear equations in one variable. So let's take a quick minute to go to the whiteboard. Okay, so in order to start this is going to be our introduction to algebra, okay? So in order to start this, we need to know, well, what is algebra? So algebra, so in short, algebra is the branch of mathematics that uses variables. Now, to be very, very clear, this is a super general definition, okay? So there's a whole lot that goes on with algebra, but just to start, just so we kind of have a general understanding of where we're at in our, our path and our adventure with mathematics, we're at the point where we're going to start seeing the alphabet in math. So algebra, that's where you start seeing the alphabet. Further, we need to know what are variables. Well, variables are letters or symbols. For us, we just use the basic English alphabet. Variables are letters or symbols that act as placeholders for numbers. So we have that algebra is where we start to see the alphabet in mathematics, and the alphabet, we call those variables. And again, that's just a letter or a symbol that acts as a placeholder for numbers. And for this series of videos, we're just going to stick with the regular old English alphabet. And then we also have just numbers that stand by themselves. So we have a constant. And a constant is a number that stands alone. So if I had something like, let's change colors here. So let's say I had something like x plus 5. Well, x would be considered the variable. And 5, because 5 is all by itself and it's not being multiplied by any kind of a variable, we would consider 5 to be a constant. Okay, now individually speaking, if we look at the x separate from the 5, we would consider the x and 5 terms. So terms in algebra are variables, constants, or the product of a variable and a constant. So we could have something like plain old x could be a term, plain old 5 could be a term. We could have something like negative 2y could be a term. We could have 4x squared that could be a term. We could have negative 17, that could be a term. One thing I do want you to note is terms can be positive or negative. And a positive term has nothing in front of it or a plus sign. So if you see a term that has a plus sign or it's at the start of an expression and there's no sign in front of it, you would assume that term is positive. If you see a negative sign or a minus sign in front of a term, you assume that one's negative. So now let's say that we consider a new expression. So let's say for this one, we had something like 7x plus 5. Well, from the previous slide, we already know that the x is the variable. We know that the 5 would be considered a constant because it's all by itself. But what is the 7? So when you're looking at an expression like 7x plus 5, what is that 7? Well, that would be considered a coefficient. So for us, a numerical coefficient is the number factor or the numerical factor of a variable term. Again, this is a very generic definition. At this point, I want you to have just a basic understanding. You can go much deeper into this, but for now, this is what you need to know. So now if we look at 7x plus 5, we would say that 7 is the coefficient of x, which is the variable, and 5 is still just a constant. It's kind of hanging out all by itself. All right, so let's look at a couple of examples of coefficients. Let's do that in black ink again. Keep it consistent. So if I had something like negative 3z, the coefficient would just be negative 3. One thing I do need to note here is that your coefficient is going to be positive or negative depending on whether the term is positive or negative, okay? If I had something like x, well, what is the coefficient of just plain old x? Technically, this is 1x, okay? We just don't write the 1. So we would say here that the coefficient is just 1. Now, what if I had negative y? Well, the coefficient here, we can see that there's no other number in front of the y, so we would again assume that there's a 1 in there. But because the y is negative, we would say the coefficient is negative 1. The one that gets students a little bit of trouble is when you have fractions. So if I had something really easy like 3/4 times x, well, the coefficient is just 3/4. But what if I had 3x over 4? These are actually the same thing. 3/4 x and 3x over 4 are identical. They're just written kind of a little bit differently. So in this case, the coefficient would still be 3/4, okay? So think of the coefficient as, well, the number in front of the x or multiplied by the x is 3, but that 3 is being divided by 4. Similarly, you could have something like, let's say we have y over 7. Well, what would the coefficient be here? If we look at this example right here, we would say, well, the coefficient on y is 1, but that 1 would be divided by 7. So the coefficient here would be 1/7. So basically, when you're dealing with coefficients, it's the number that's being multiplied by the variable. Okay, just be careful. There's some special things that can happen. Positive versus negative does matter, and look out for those fractions. Okay. Now, moving along, we're getting to like the gist of algebra, what we're going to be dealing with in this video. So for this video, we want to look at algebraic expressions. So an algebraic expression, we generally just call them plain old expressions. The algebraic part is kind of assumed. So algebraic expressions are the sum or difference of terms. Now, this is a very generic definition. It's not super formal. It's not super technical. Some books you would see that an algebraic expression is a combination of sums, differences, products, quotients, or it would say something like an algebraic expression is the combination of variables, constants, and operations. So operations being addition, subtraction, multiplication, division. You might even see exponents in there. But just for now, the general, really generic definition of an expression is that we're dealing with the sum or difference of terms. So what I want to do now is look at a few examples. We're going to determine how many terms we have. We're going to determine the coefficient of each term, whether they're positive, whether they're negative. Okay, so let's look at examples. So for our first example, let's say that we have negative 3x minus 12. Okay, well, for this particular example, we have two terms, negative 3x and negative 12. For negative 3x, the coefficient is negative 3. And then for the constant negative 12, you will sometimes have books or different products ask you for like the coefficient of a constant. If we were looking at negative 12, we would say the coefficient is just negative 12. All right, so we have two terms. The coefficient on the x is negative 3. We have a constant 12. That's all she wrote. Let's look at another one. What if I had x squared plus 4x minus 7. Well, here I have three terms. I have the x squared, I have the 4x, I have the negative 7. For the x squared, my coefficient would be 1. For the x, my coefficient would be 4. And again, for the constant, I don't generally ask for coefficients on constants, but you would say the coefficient would just be negative 7. So that's how we look at algebraic expressions. Now, when it comes to algebraic expressions, we're somewhat limited algebraically at this point in our math career, okay? So at this point, we have two things that we can do with algebraic expressions. So two things we can do with expressions. The first is we can evaluate them. And we evaluate them for given values. The second thing we can do is simplify them. So that's what I'm going to do for the rest of this video, is we're going to look at these two really important things that we need to understand about algebraic expressions. So first up, evaluating. So this is the process of replacing the variables with given values and then using the order of operations to simplify. Now, it's been a while since we've talked about the order of operations, so let's do just a quick overview. So for the order of operations, a lot of us remember the order of operations by PEMDAS, or please excuse my dear Aunt Sally. And so those lead you to believe there are 6 main steps. For us, we really look at it as 4 steps. So the first step is deal with all grouping symbols. So in PEMDAS, that would be like parentheses, but really it's parentheses. You can have braces and brackets. You could even have a square root symbol. You could have absolute value. So anytime you have work inside some kind of grouping symbol, you want to do that first. The second step would be exponents. Some people will also put the square roots down here with exponents, doesn't really matter. So exponents, if you've got anything with exponents, take care of those exponents. Step 3, you deal with multiplication and division. You just always have to work from left to right. All right, so in PEMDAS, that's the M and the D, and please excuse my dear Aunt Sally, this is the my and the dear. The thing that you need to know is you don't do multiplication and then division. You do the multiplication and division kind of at the same time, and just whichever one shows up first in the expression, you do it first. And then the fourth and final step would be addition and subtraction. And again, work from left to right. So in PEMDAS, this would be the A and the S, and please excuse my dear Aunt Sally, this would be the Aunt and the Sally. And just like with multiplication and division, you don't do all of your addition and then all of your subtraction, you do them from left to right. So let's practice evaluating. I have several examples I want to look at. So examples of evaluating. And I'm just going to put here, evaluate each expression for the given values. And that is a key point right here. When you're evaluating, you have to be given a value for the variable. You don't just make one up. The particular problem is going to ask you, hey, evaluate this for this very specific value for X, Y, Z, whatever. So for our first example, we have a really simple one. We have 5x plus 7, and we want to evaluate for X equals -3. So what I do is anywhere I see an X, I'm going to replace the X with a -3. So I've got 5 times -3 plus 7. Now I need to follow the order of operations. And if we go back one slide, we know that for the order of operations, I have in this particular problem, multiplication and addition. According to the order of operations, I want to do the multiplication first, the addition second. So we want to take care of our multiplication first. So 5 times -3 is -15. I'm going to drop down whatever I have left, which is +7. And then finally, -15 plus 7 is -8. And that's it. That's evaluating. So let's look at an example now where we have two variables. So what if we had -8x minus 6y, and we want to evaluate for x is 2, y is -4, okay? So anywhere I see an x, I'm going to replace the x with a 2. Anywhere I see a y, I'm going to replace the y with a -4. And I would encourage you to use parentheses when you replace the variables with numbers. So -8 times 2 minus 6 times -4. And just like in the previous example, we have multiplication and then in this case subtraction. We do the multiplication first, subtraction or addition second, okay? So let's start with -8 times 2. Well, -8 times 2 is -16. And then if I look at -6 times -4, well, two negatives make a positive, so that's going to be +24. And then -16 plus 24 is going to be +8. So there we have our first two examples. Let's keep going. Let's say that we have, in this case, x squared plus 2x minus 9, and we're going to evaluate for x equals 3. All right. So anywhere I see an x, I'm going to replace it with a 3. So x squared is going to be 3 squared, and then plus 2 times x, where x is 3, and then minus 9. So in this example, I have exponents, I have multiplication, I have subtraction and addition. The first thing in the order of operations would tell me to deal with my exponents. So 3 squared is 9. 2 times 3 is 6. And then just drop down anything that you have left, which would be minus 9. Well, 9 plus 6 minus 9. In this case, I've got addition and subtraction. I'm going to work from left to right. So 9 plus 6 is 15. And then 15 minus 9 is 6. So there you have it. All right. Now that one was pretty easy because the value for the variable was positive. Anytime you have exponents and the value for the variable that you're replacing is negative, you got to be a little more careful. So let's try x squared minus x plus 7, and we're going to evaluate for x is -1. So just like before, anywhere I see an x, I'm going to replace it with a -1. Please use parentheses. So first we have -1 squared. Well, we have a negative inside parentheses. So when you have a negative inside parentheses, the exponent determines whether your product is going to be positive or negative. If your exponent is even with a negative inside parentheses, you're going to get a positive product. If you have an odd exponent with a negative in parentheses, that's where you get the negative product. Here, we're going to get +1. So it's going to be just -1 times -1, which is 1. Next, we have -1 times -1 again, which is +1. And then we have +7. And now I have just all addition, so I work from left to right. 1 plus 1 is 2, plus 7 is 9. So just watch out when you're replacing variables with negatives, especially if you have exponents. All right, let's look at one or two more examples. So this is kind of a weird one because we have something that looks like a fraction. Okay. And we're going to evaluate for x equals 6. You can do this two ways. You can just plug everything in all at once and evaluate and then simplify, or you can look at the top separate from the bottom and then evaluate. So let's say we just look at the top and the bottom. So let's say we have -7 times x, which is 6, plus 8. Well, -7 times 6 is -42. And then negative 42 plus 8 is going to be, let's see what, negative 34. We can look at the bottom now. We get 3 times x, which is 6, minus 4. Well, 3 times 6 is 18, minus 4 is 14. Okay, so we have these two separate values. What do? Well, negative 34 is the top, 14 is the bottom. So let's just plug them back into the top and the bottom. So now we have negative 34 over 14, and let's simplify and see how this works out. So let's see, negative 34 and 14, they at least have a 2 in common. So I would divide each of these by 2. And I end up getting negative 34 divided by 2 is what? Negative 17. And 14 divided by 2 is 7. So our final answer would be negative 17 sevenths. All right. So again, one way to do it is just plug everything in and then simplify, or you can look at the top separate from the bottom, fill in the final evaluated number for the top, final evaluated number for the bottom, and then reduce. One other example, we have, let's say, 2xy plus 7x all over 5x squared minus 2y. And we're going to evaluate for x is 3, y is 0. So the other way you can approach evaluating something that looks like a fraction is just plug everything in all at once. So anywhere I see an x, I'm going to put a 3. Anywhere I see a y, I'm going to put a 0. All right, so I've plugged everything in at this point. So anywhere I had an x, I plugged in a 3. Anywhere I had a y, I plugged in a 0, and I just rewrote the whole expression, replacing those values for the variable. And now I want to simplify. So in the numerator, we have multiplication and we have addition. So we've got to do the multiplication first. So first I have 2 times 3 times 0. Well, 2 times 3 is 6, but multiplying it by 0, I just get 0. Got to remember to go back to black ink. There we go. So I get 0 plus, and then 7 times 3 is 21. And then for the denominator, we're going to have to do a couple of steps here. I get 5 times 3 squared. Well, I've got to do the exponent first. So I get 5 times, well, let's see, 3 squared is 9. And then minus, well, 2 times 0 is just 0. So I get minus 0. Simplify again. In the numerator, I get just 21. In the denominator, I get 5 times 9, which is 45. Minus 0 is just going to be 45. And then I want to see if I can reduce. Well, 21 and 45 are both divisible by 3. 21 divided by 3 is 7. 45 divided by 3 is 15. And there's my final answer. So when it comes to evaluating stuff where you have an expression that kind of looks like a fraction, you can do it like I did here. I just plug all the values in for the variable and then just simplify slowly. Or you can do like we did on the previous slide right here, where we evaluated the top of the fraction, the numerator. We evaluated the denominator of the fraction separately, and then we put it all back together and reduced. Whichever one you're comfortable with is fine. All right, now that's pretty much it for evaluating. So if we go back a few slides, let's see, let me go over one more. All right, so there are basically two things we can do with expressions. One, we can evaluate them for given values. We've practiced that. The second thing that we can do is to simplify the expressions. So let's see what that looks like. So simplifying expressions. This is also called combining like terms. So the first thing we have to investigate is, what are like terms? Well, like terms are terms that have matching variable parts. That means they have the same variables, the same exponents, okay? So what we do to combine them, we add or subtract the coefficients spelled that wrong. Bless my heart. We add or subtract the coefficients and keep the variable part. Okay, so let's look at what like terms would look like, and then we'll practice combining. So consider like terms. So here are examples of like terms. 5x and negative 7x. If you look here, they have matching variable parts. We could have something like 12x squared and 2x squared. They have matching variables, matching exponents. We could also have something like 15xy and negative 8yx. Now, these look slightly different. It looks like they're not the same because you have x then y in the first example, and then you have y and then x in the second example. So the variables are out of order. However, it doesn't matter the order of the variables. What matters is that the variable parts are the same. Same variables, same exponents. You have an x to the first power and a y to the first power in both terms. Non-examples. So non-examples are things that would not be like terms. So something that would not be a like term would be like 5x and negative 7x squared. While you have the same variable, you don't have the same exponents. Another non-example would be something like, let's say we had 15x squared y and then negative 8y squared x. So in this case, you have the same variables, which is great, but you got to look carefully at the exponents. While you have the same exponents, you have exponents of 1 and 2, the exponents are on the wrong variables from one term to the next. So in the first term, the squared variable is the x. The second term, the squared variable is the y. Those are not like terms, okay? So make sure you really understand the difference between like terms and terms that would not be considered like. Now, let's look at some examples. So examples. And I'm just going to put combine like terms. We'll start with really, really super easy examples. We'll do 2 of them. And then we have to consider a property for more complicated examples. So first up, let's say we have 5x minus 3x. Well, first, make sure these are like terms. They are. And then look at the coefficients and just do what's being asked. We basically have just 5 minus 3. Well, 5 minus 3 is 2. And then we just keep the x. That's it. Next up, let's say we have negative 7y minus 15y. So again, do we have like terms? Yes. We have a y to the first power in both terms. So what do? Well, we take the negative 7 and we subtract the negative 15. Well, when you're subtracting numbers like this, you basically can add the 7 and the 15 and just keep it negative. So 7 minus 15 is really, let's see, 22. So we get negative 22y. Now, what if we had something like, let's say we had negative 12x plus 7 minus 5x. So we have 2 different types of terms here. We have what we would consider like terms, the negative 12x minus the 5x. The 7 is not considered a like term with the 12x and the 5x. That's okay. So what we do is we combine the terms that are considered like terms. So we're going to combine the negative 12x and the minus 5. So we ask ourselves, well, what is negative 12 minus 5? That would just be negative 17, keep the x. And then this plus 7, it has nothing to combine with, so we just bring it down. Okay? So you can have an expression that has a mix of terms, combine what you can, and then just leave what you can't. So what if we had something like 2x squared minus 7x plus x squared minus 12 plus 2x? So this one's kind of complicated because you've got 3 things happening. You've got x squared terms, you've got x terms, and then you've got constants. So anything that's similar can be combined and then just write your new expression. Basically, combining like terms is sort of like cleaning up crumbs on a table after a meal. You're just sort of like combining everything into one pile. So let's look at the pile of x squareds. So I've got 2x squared plus x squared. So the coefficient on this x squared right here would be like a 1. So basically I have 2 plus 1 is 3. So I have 3x squared. Now let's look at the x's. So I have negative 7x plus 2x. Those are considered like terms. So I want to take my negative 7, add 2, I get negative 5x. And then finally, we have this constant here all by itself. There's nothing to combine it with, so we just drop it down. And that's it. Okay, so you can have something really simple like examples A and B, or you can have things that are a little bit more complicated like C and D. Now, before we can move on, we have to consider what we would do if we had parentheses. So what do we do if an expression has parentheses? We know that's feasible because if we go back and look at our order of operations, the very first step to the order of operations is deal with grouping symbols. And one of those sets of grouping symbols was parentheses. So it goes to show that perhaps that can show up when we're trying to simplify an algebraic expression. If this happens, we use the distributive property. Ooh, that got messy. So the distributive property allows us to, whoops, got ahead of myself, allows us to multiply through addition or subtraction. So what does that look like? If we had the expression b plus c and the whole expression was multiplied by a, well, what we would do is we would multiply the a by the b, and then we would multiply the a by the c. So that allows us to multiply through addition. The same thing would work if we had b minus b. It would just be ab minus ac. So let's look at a quick example of just distributing, and then we're going to do some of the combining like terms, okay? Distribute. All right, so example A, let's say we have 5 times 2x minus 3. Well, all I want to do is take the 5, multiply it first by the 2x. So what we would do here is we would multiply the 5 and the 2. 5 times 2 is 10, keep the x. Then I want to take the 5 and multiply it by negative 3. Well, 5 times negative 3 is negative 15. And that's it. We have distributed. And there's nothing to combine, so we would just leave our final answer as 10x minus 15. Okay, when you're distributing, make sure you fully distribute. Everything in parentheses gets multiplied by what's in front of the parentheses, and watch your signs. Let's try a couple more. So let's say that we have negative 6 times 4x plus 5y. Okay, so now we do have a negative that we're multiplying by, so be cautious. Negative 6 times 4x. Well, negative 6 times positive 4 is negative 24. Keep the x. And now we're going to multiply negative 6 by 5y. Negative 6 times 5 is negative 30. And then keep the y. And again, you have unlike terms, so there's nothing that you could simplify here. Let's do one more like this, and then we'll start looking at kind of more complicated examples where we would have to combine like terms when we're done distributing. So let's say we have negative 11 times 3x plus 5y minus 9. So again, watch your signs. You're going to be dealing with positives and negatives here. I'm going to start with negative 11 times 3x. Well, negative 11 times 3 is negative 33. Keep the x. Now we're going to look at negative 11 times 5y. Negative 11 times 5 is going to be negative 55. Keep the y. And then finally, we're going to look at negative 11 times negative 9. When I multiply two negatives, I get a positive. And then 11 times 9 is 99. And that's it. All right. So we already know how to combine like terms. That's the first half of this screen. The second half of the screen, we learned that, hey, sometimes these expressions can have parentheses. What do? We learn that we distribute. The distributive property allows us to multiply through addition. And we just did 3 examples of this. For the final bit of this video, let's look at what happens when we have to get rid of parentheses and combine like terms. So examples. Distribute and simplify. Okay. So first example, let's say that we have 4 times 2x minus 1 minus 5 times 3x plus 6. So we're going to start by looking at kind of like just the first half of the problem. So we're going to look at the 4 times 2x minus 1. Well, 4 times 2x is just 4 times 2, which is 8x. And then 4 times negative 1 is negative 4. Now we move to the second half of the problem, which is negative 5 times 3x plus 6. So negative 5 times 3x, well, we start by looking at the negative 5 and the 3. That would give us negative 15. And then we just keep the x. And then negative 5 times 6, well, negative 5 times 6, we're going to get a negative, and it's going to be negative 30. So then let's kind of look over what we have here. We now have 8x minus 4 minus 15x minus 30. We do have sets of like terms. We have x terms, and then we have constant terms. So let's combine them separately. Let's start with the x's. Generally speaking, when you are combining like this, you do simplify the variables first and the constants last. That's just kind of the form that we write it in. When you get into higher level courses, you'll find that that's kind of called standard form. But for now, let's just go ahead and look at the variables. So I've got 8x minus 15x. Well, I really have 8 minus 15, which would be negative 7, keep the x. And then looking at the constants, I have negative 4 minus 30, so it's negative 4, and then subtract 30 more. So it's negative 34. And that's it. Let's look at another one. So for this one, we have negative 7 times 3y minus z. Do be really careful when you're in a class where you have to like write things out. Variables, once we start adding variables, it can get really messy because some students don't have the best penmanship, and that, it's fine. Be careful with z's. I like to always put the little line in my z to make it really clear to the reader that that's a z and not a 2, okay? So be very, very careful when you start incorporating these variables. Z. Well, I'm going to take the negative 7 and I'm going to multiply it by positive 3y. So negative 7 times 3 is negative 21. Keep the y. And then negative 7 times negative z. When I multiply two negatives, I get a positive. And there's technically a coefficient on this z of just a 1. Well, negative 7 times negative 1 is positive 7. Keep the z. Now we're going to look at the second half of the problem. And I want to point out something here. Here we have just minus and then a set of parentheses. In all the examples we've done so far where we're trying to get rid of those parentheses, we had a number in front of the parentheses. Well, there is a number here. It's just not written out. A lot of times in math where you see something and a number's missing, you have just a variable or just a set of parentheses, there's an assumed 1 there. So what we're really distributing here is negative 1. So negative 1 times 5y. Well, negative 1 times positive 5 is negative 5. And then I keep the y. And then negative 1 times positive 6z. Negative 1 times 6 is negative 6. Keep the z. Okay? So now we have y terms and we have z terms. So we're going to look at the y terms, and then we're going to look at the z terms. Okay? And generally when you have two variables like this, something really simple, alphabetical would be the way to go. So we would do the y's before the z's. So negative 21y minus 5y. Well, negative 21 minus 5 is negative 26, keep the y. And then when I look at the z's, I've got positive 7z minus 6z. Well, 7 minus 6 is just 1. So I'm going to get minus or plus 1z. Notice I didn't physically write the 1. If you have just 1z or 1x or 1y, you write just the variable by itself. You don't write the 1. All right. And one more example. We'll make this the final one for this video. We have x squared plus 5x minus 9 minus, and then in parentheses, we have x squared minus 3x plus 1. Okay? So for the x squared plus 5x minus 9, there's no parentheses or anything that needs to be distributed. So what I'm going to do is I'm just going to bring it down. I'm going to rewrite it. And then just like in the previous example, in front of this set of parentheses is technically a negative 1. So let's go ahead and distribute the negative 1. So negative 1 times x squared, again, in front of the x, there's technically a 1 there. So what we have is negative 1 times 1, which is just minus 1x squared. Hang tight. And then I've got negative 1 times negative 3x. So that's going to give me positive 3x. And then finally, I have negative 1 times positive 1, which is minus 1. So now let's evaluate what we have. We have x squared plus 5x minus 9 minus x squared plus 3x minus 1. So within this giant expression, we have three things happening. We've got x squared terms, we have x terms, and finally we have constant terms. So we have three things that we need to combine. Let's start with the x squared. So generally, if you have same variables but different exponents, you go highest exponent to lowest exponent. So I have 1x squared, because remember, we don't write those ones, but they're hidden there. I've got 1x squared minus 1x squared. Well, what's 1 minus 1? It's 0. So this basically says that I have 0x squared, so we can say those cancel out, okay? So let's move on to the plain old x terms. So here I've got 5x plus 3x. Well, 5 plus 3 is 8, so I have 8x. And then finally, we need to look at the constants. I'm going to mark those out so you can see here we're left with minus 9 minus 1. So negative 9 minus 1 would just be negative 10. So believe it or not, after starting with that giant expression, it simplified all the way down to 8x minus 10. Okay, so let's do a really quick recap. So we started out with some just really general, very generic definitions. First, algebra is the branch of mathematics that uses variables. So when you start seeing the alphabet in math, you're dealing with algebra, and that's a really generic definition. There's so much more to algebra, but for now, just know that variables, algebra. Now, variables we know are letters or symbols that act as placeholders for numbers. And then we also can have numbers that are kind of all by themselves. So we call those constants. A constant is a number that stands alone. So we looked at the example x plus 5. Well, we clearly have two things happening there. We have the x, we have the 5. How do we define those? Well, those are called terms. So terms can be variables all by themselves, constants all by themselves, or you could have the product of a variable and a constant. So we looked at some examples. We did note that terms can be positive or negative. Next up, what if you have a term where you have the product of a variable and a constant? What do we call the number? So we looked at 7x plus 5. Well, we know x is the variable. We know 5 is the constant. Well, what on earth is 7? 7 is called a coefficient. So a coefficient is a numerical factor in a variable term. We then looked at some examples of different terms and their coefficients. Next, we talked about an algebraic expression. That's kind of the whole point of this video. An algebraic expression is basically the sum or difference of terms. Now, I did note at that time that that's not a very technical or formal definition of an algebraic expression. So if you read in a textbook, they'll generally say an algebraic expression is the combination of numbers, variables, and operations and exponents. That's great. This is just kind of for now. Basically, you're combining terms by adding and subtracting. So we looked at some examples of terms and what their coefficients would be. Next, we looked kind of further at just what we can do with algebraic expressions. So at this point in our math career, we can evaluate algebraic expressions or we can simplify them. So we found that evaluating was the process of replacing the variables with values and then using the order of operations to simplify. We did a brief overview of the order of operations, and then we just looked at lots of examples of evaluating. So next up, we looked at simplifying algebraic expressions. Now, when you simplify an algebraic expression, we generally call that combining like terms. Okay, so like terms are terms that have matching variable parts. And then to combine like terms, you add or subtract the coefficients and you keep the variable parts. We did look at examples of like terms and examples of terms that would not be considered like. Make sure you have a firm understanding of what like terms are. And then we just looked at lots of examples of combining like terms, and we had to add a property in. We looked at some really basic examples of combining like terms, but then we came to this conclusion, well, what do we do if an expression has parentheses? Well, you have to eliminate the parentheses, and we can eliminate parentheses by using the distributive property. So the distributive property allows us to multiply through addition and subtraction, and in doing so, we get rid of the parentheses. So we looked at examples of just evaluating, and then finally, we looked at examples where we had to distribute and then also simplify, okay? So that's kind of the overview of just what algebraic expressions are. Remember, this is going to be a really, really, really long series of videos on solving linear equations in one variable, or just working with linear equations in one variable. So I've broken this huge series of videos into 3 parts. The first part is just solving linear equations in one variable. So today was the start of that. We're next going to look at one-step equations, multi-step equations, equations that have fractions, equations that have decimals, and then classifying equations. After that, we're going to move into part 2, which is all going to be about word problems. And then part 3 is going to have a little shift in it. We're going to look at linear inequalities in one variable. All right, so that's it for this video. Next up, we'll look at the beginning of solving equations and the difference between what is an expression and what is an equation. All right, see you next time.